Hello dear students, all of you, pleasant evening. Welcome to Infinity Learn by Sri Chaitanya. Hi dear students, in functions earlier we have discussed many kinds of subtopics. Of those, we have seen types of functions, domain related problems, range related problems and many more things, right. So, in this session let me give you the briefing about the main points of periodic functions, right. You see friends, periodicity is the basic nature that we can observe in nature, right. You see, the days of a week, they are periodic, the months of an year, you see, they are periodic, even we can see seasons, they are periodic. In the same way, you see, we can observe the same kind of periodic nature even in functions also. So, before we go to the special points, first let us define what a periodic function is, right friends. Shall we start? Yes. Friends, a function, a real function f from A to B is said to be a periodic function if there exists some t, a positive number t, such that f of x plus t is equal to f of x for all x. Yes, there must exist some positive number t such that f of x plus t is f of x for all x. You see, we can observe many periodic functions in trigonometry. You just take f of x is sin x function. Yes, can you say some number t, some positive t such that f of x plus t is equal to f of x? Why not? You just take f of x plus 4 pi, you take, yes, it is sin of x plus 4 pi, which is sin x itself always. So, since there exists some number, positive number t here in the form of 4 pi, this is a periodic function. And of course, even sin of x plus 2 pi also sin x itself. Such least positive t is called the fundamental period of this particular function. For example, even for the same function, sin of, that is f of x plus 2 pi is also f of x. Am I correct? That is sin of x plus 2 pi is also sin x, and we can't find a number less than 2 pi such that f of x plus t is f of x. So, for the function sin x, you can say that 4 pi is a period, 6 pi is a period, 8 pi is a period, even 2 pi is also a period, but the fundamental period, or simply we call period, is nothing but 2 pi. 2 pi. The same can also be observed through the graph of sin x also. You just take the graph of sin x, you see 0 to 2 pi, this is the graph of sin x. You can observe that the same graph repeats, same graph repeats. You see this length 0 to 2 pi length, the same unit is getting repeated. From the graph also you can easily comment, you can easily find whether a given function is periodic or not. Even we can observe the fundamental period also, right friends. So, in the same way we can observe cos x is also a periodic function. You just observe the graph of cos x, you see cos 0 is 1, this is the graph of cos x from 0 to 2 pi. You can observe that the same thing repeats, yes, the same thing repeats, for every 0 to 2 pi. So, cos x is also a periodic function with period 2 pi. In the same way, you just recall the graphs of tan x, cot x, cosecant x, secant x. You can observe the periodic nature of this particular function. You see friends, you just take tan x also. I think you know the graph of tan x. This is the graph from minus pi by 2 to pi by 2. Then suppose this is pi, this is 3 pi by 2. If you just see, this is the graph. You see this part, the same part repeats. So, this length is pi. Moreover, you can observe that tan of x plus pi is always tan x whenever it is defined. So, friends, tan x is a periodic function with period pi. Okay. So, apart from these, my dear friends, we can also find certain interesting algebraic functions. There is one interesting algebraic function which is not trigonometric but periodic. Can anyone guess? Array, it is not x, it is not x square, it is not, you see, like we have many functions in algebra like logarithmic function, exponential function, all these are not algebra, I mean periodic, right? But there is one interesting function which is periodic. Can you guess? Yes friends, step x, y is equal to fractional part of x which is defined like x minus step x. You know already we have discussed the graph of this function in the earlier class. You can see that the graph of this function is, you just see, say this is 1, 0, 1, 2, 3, 4. You can observe that from closed 0 to 1, this is open here, because 1 to 2 it will be the same graph, you are going to get the same portion of the graph. Yes, you see the same portion repeats for every length of 1 unit. So friends, this is an important function which you need to remember. Fractional part of x is a periodic function with period 1 unit. Okay friends. So, what are the important points that we have highlighted so far? Point number 1 friends, what is a periodic function? Second, certain periodic functions and their fundamental periods we have observed. Okay. So, we can say, you see, sin x, cos x and cosecant x and secant x are the functions which have period 2 pi. Whereas friends, tan x and cot x are the functions which have period pi only, and fractional part of x is a special function which has period 1. Okay friends, I can say this is point number 2. Next, third point, we have seen, you see friends, if generally we talked in transformations, if f of x is a periodic function with period t, we might have seen the transformed graphs like k into f of ax plus or minus b plus or minus c. You take this function. Here you can see, I told you the graph of this function, you see the period cannot be disturbed by k or c or b, because of these transformations the graph moves either left or right or upwards or downwards. But this a, the x coefficient, is effective to influence the period. So, its period is going to be t by mod a. This is an important point friends. If f of x is a periodic function with period t, then you take any combination of these, the period is going to be neither k nor c nor b is going to influence the period, because we have seen the transformed graphs of such functions, only a can disturb the period. So, friends, this is t by mod a. So, after this point friends, you can observe point number 4, what could be the period of sin square x friends? Undoubtedly 2 pi is okay, but even though I take pi plus x, sin of pi plus x is minus sin x square is there, no. So, sin square of pi plus x will also be sin square x, same function comes. So, friends, sin square x has period pi itself rather 2 pi, but if you take sine cube x, sine cube of pi plus x will not be minus, will be minus sine cube x, but you won't get sine cube x. So friends, in fact sine power 2n x, if you are given even power x, in the same way cos power 2n x, even cosecant power 2n x or secant power 2n x will give the period pi itself rather 2 pi. Okay. Whereas friends, for the same you can observe that, for the same, if the power is odd number, there is no change in the periodicity, it is going to be, I can say, so sine power 2n plus 1 of x, or like sine cube x, sine power 5x and all, this is cos power 2n plus 1 into x. In the same way others also will have period 2 pi itself. Whereas friends, tan power nx, whether n is even or odd, the period is pi itself. You know tan x period is pi, but tan square x period is not going to be pi by 2. You see, because if you write pi by 2 plus x in place of x, you won't get like tan power nx. So tan power nx period is pi. Apart from this, my dear friends, you can also observe the period of mod sin x. You see friends, sin x graph is very clear. This is the graph of sin x. Mod sin x will become like this. So mod sin x will have period pi itself. So in the same way mod cos x also, and mod tan x don't expect it to be pi by 2, even mod tan x means the negative portion comes like this, it is also a periodic function with period pi itself. So its period is also pi. This is another point which we need to remember. We have given definition of periodicity of a function, then we have done basic observation, then you see we have seen these points, sin power 2n, sin power 2n plus 1, tan power nx, these. Apart from this friends, if, and another point, if you are given fractional part of ax plus b, the period is going to be 1 by mod a, because I told you fractional part of x is a periodic function with period 1, right. Then friends, if you are given combination of certain functions like you see k f of x plus or minus L g of x by m h of x plus or minus t some p of x, you are given combination of certain functions are given where all the 4 are periodic with different periods, say t1, t2, t3, t4. In that case, you see friends, you try to take LCM of these periods which will give you the period of this function. Sometimes there is a chance to get its submultiple also. So I say that when combination is given, the period is either LCM of these or its submultiple. Suppose its LCM is t, sometimes it can be t by 2, t by 3, t by 4 also. Please check the situation and proceed further. This is point number 8. Then point number 9, my dear friends, while finding LCM, suppose you are given fractions, you got like 2 by 3, 7 by 2, 1 by 5 kind of, how to find LCM of fractions? So in this case friends, LCM of numerators by HCF of denominators. For example, LCM of numerators is 14, HCF of denominators is 1. Okay. And we can also find LCM of irrational numbers having the same irrational part. For example, 2 pi by 3, 3 pi by 4, something is given. Pi is common irrational part, you put aside, you just take LCM of 2 by 3 and 3 by 4, LCM of numerators is 6, HCF is 1. So, 6 pi is the LCM. Friends, at the same time another interesting point is, friends, there does not exist LCM of a rational number and irrational number. What is the LCM of 2 and pi? Do not say 2 pi. If you say 2 pi, LCM means this divided by each number must give a natural number. You will not get 2 pi by 2 is not a natural number. So, LCM of a rational and irrational number does not exist, In that case, we do not say that the function is periodic. Maybe you can take like sin 2x is a function, sin or cos pi x is a function. You see, for this the period is pi, for this the period is 2. So, totally together we say that this is not a periodic function, right. Apart from this, friends, you just take function like mod sin x plus mod cos x. If you take it as f of x, when you see separately its period is pi, mod cos x period is pi, LCM is pi. In fact, if you just take f of x plus pi by 2, this becomes, you see, mod cos x plus mod sin x. That is, when actually period is pi, I mean LCM is pi, but it is for its submultiple itself it is getting the recurrence, because this is becoming this, this is becoming this. Such situations now and then come across, so be careful with this, and the relevant problems will be done in the next class, right, friends. So, point number 1, the definition of a periodic function, certain standard periodic functions, then how to find the period related, certain important points are highlighted. Fine, friends, we will just go through the problems in the next class, right. That is all for the day. Stay tuned to Infinity Learn by Sri Chaitanya. Thank you.